Why do we study measurement, which has affected scientific technology? Measurement developed as humans started to produce and store grains and bartered for food, clothing, and shelter. The first measurements were based on the human body or objects from nature. However, this meant that the standards differed for each person, leading to a need to unify the units. The first thing a ruler does after building a country is to create a system of governance. While the ruler makes norms and legal systems in many areas including politics and economy, the first thing they create and systematize is measurement. Governing a country is costly, buildings need to be built, armies raised, and government officials selected. To do so, the governments need tax people, and to impose the tax fairly on everyone requires a measurement system. In ancient times, Asian countries recorded the amount and the person for whom the tax was collected on wooden tablets, called mujian. Mujian refers to flat wooden pieces that Asian people used when paper was not easy to get. Often used as tags tied to objects, various things were written on these wooden pieces, ranging from religion, medicine, transported goods, to even food. They were even used as a simple ledger about the tax that was gathered. Government officials recorded the name of the person paying the tax and how much the person paid on the wooden pieces. The wooden tablets are an important source of information on the measurement used at the time. The fact that measurement is the basis of a nation and the basics of science is well illustrated on the walls of ancient ruins, as well. Although only the ruins remain now, the Hwangryong Temple, a temple in Korea, was the greatest temple during the Jin Dynasty that provided spiritual support for its people. And it is said that there was a Buddha statue called Janggyeoksang at Jumdang, a building that houses the Buddha statue of Hwangryong Temple. The secrets of ancient measurement are hidden within the name Janggyeoksang. In ancient times, Asian people called the length of about 9.8 feet jang. Because the height of the Buddhist statue was 1.6 jang, the Buddhist statue was named Janggyeoksang, with yuk meaning 6 and sang meaning form. As such, measurements were necessary when making Buddhist statues and building temples. If there were no tools or units to measure set amounts, it would have been impossible to have architecture and civil engineering and thus make Buddhist statues. In other words, without it, the ancient kingdoms could not have been created in Korea. Because measurement systems existed, ancient kingdoms such as Goguryeo, Silla, and Baekje could be created and have their historical legacies. The unit chuk appears often when looking at ancient Korean historical text. Why is this the case? A full understanding of chuk, a measurement unit for ancient Korean kingdoms, gives us clues about traditional scientific technology. Then what exactly is chuk, and why does it appear so often in Korean history? What impact did it have on the ancient scientific technology? Chuk is the most basic standard for measurement that can be used to measure length and volume. Why do we study the standards and uses of measurement systems from ancient kingdoms? We study measurement systems created by the ancient kingdoms because it allows us to understand politics, economics, and culture of the time at a glance. Guanan, the basic Chinese unit of measurement for mass. This unit was made based on the fact millets, a type of grain, have a consistent weight. The fact that millets became a standard for a unit of measurement shows that it was produced in mass and consumed by many. The distance between the thumb and middle finger of a fully stretched hand was used as a unit for length, and the area where a person could lie down with their arms and legs extended was used as a unit for area. In other words, the body was used as a standard for measurement in China. Just as was the case in Asia, the Western world also made measurement systems based on the human body. As was mentioned before, cubit is one of the units used to measure length in ancient times. The cubit is the length from the elbow to the end of the middle finger. Depending on the period and region, the length differed. Feet used in the imperial system was made based on the size of the men's feet. Although it is not a standard unit internationally agreed upon, carat is a unit that we use in our daily lives when buying gold rings or necklaces. The K in 24 karat, 18 karat, and 14 karat indicates how pure the gold is. 24 karat means the gold is 99.99% pure gold and the purity decreases as the number gets smaller. Here the unit carat refers to 1/24 of the total. This term comes from carob, a type of plant that grows in the Middle East. The people from this area traded gold and salt based on the amount of dried carob in a fist. Thus, carob became the standard for weighing goods. An adult's hand can hold 24 carobs in a handful, thus 99.99% of pure gold is marked as 24 karat. We also use carat when measuring the weight of diamonds. 1 carat is 0.2 grams, so a 10 carat diamond is about 2 grams. Why do we use carat specifically for diamonds? This unit also originates from carats. The seed from a carob tree is relatively consistent at 0.2 grams. In the past, because there was no scale to weigh small and light objects like diamonds, carob seeds were used as a standard. Now let us learn about the units of petroleum, a type of fossil fuel. The unit used is called a barrel. Barrel, also marked as BBL, is a unit used to measure the volume of crude oil or various petroleum products. How did this unit, barrel, come about? A barrel is a cylindrical container with a bulging center. The container is made of wood and it has a steel frame around the circumference. As oil development started to flourish in the late 19th century, the crude oil extracted from the underground was stored or transported in wooden containers, barrel, which had been previously used for storing alcohol. Since then, barrel became the unit of production in sale petroleum. Originally, 50 gallons made up a full barrel. However, only an average of 42 gallons was delivered to the destination because the oil would evaporate or leak in the process of storage or transportation. Afterwards, the quality of material used for the containers and method of storage improved to prevent changes to the amount of crude oil during transportation, and one barrel now consists of 42 gallons. Of course, there are also instances where liter is used instead of barrels when buying and selling oil, but because international oil trade usually uses American dollars, barrel is often used as the basic unit. Carat and barrel are not internationally recognized standard units of measurement units, but they still play an important role in trade between countries. Unlike the past, various goods are now being traded between countries in large volumes. If each country had its own method of measurement, proper trade would not be possible. After many scholars pondered on how to unify the measurement system, they thought of the metric system, a standard that would not change with time. Why does the world need a universal measurement system? Solon was an Athenian poet, a general, and an outstanding politician from around 600 BCE. Athens was undergoing much turmoil at the time. In particular, many farmers were on the verge of bankruptcy. Farmers with debt had to pay an interest of over 20% a year, and if they failed to do so, their land was taken away and many were even sold into slavery. Merchants were dissatisfied because they could not participate in politics although they made a lot of money. Eventually, the farming community which had supported the whole society collapsed, the gap between the rich and the poor widened, pushing Athens to the brink of disintegration. However, Solon came around and turned things around for Athens. The first thing Solon did was fix the economy. Because there was no future for Athens without the farmers, the first thing he did was think of a way to save them. He returned the land taken from the farmers with debt and freed those that were enslaved, returning them their original status. Then he divided the citizens of Athens into 4 classes and gave each class different rights and obligations. He also unified unit of measurement so everyone could pay tax according to their status. Due to Solon's efforts, Athens was able to regain its stability. Here it is important to take note of how important unification of measurements is in managing a country. Ancient Egyptians were already using the solar calendar and had advanced measurement technology which allowed them to build pyramids. They used cubits, length from the elbow to the end of the middle finger, as a unit of measurement for length. Greeks also used the image of elbows in their hieroglyphics, which originated from Sumerians in Babylonia. According to scholars, the interior of pyramids used bricks that were cut using the royal cubit unit, a sum of the length from the pharaoh or priest's elbow to the tip of their middle finger and the width of the palm, while the exterior was made using the shorter cubit, length from an average subject's elbow to the tip of the middle finger. Cubits later became the basis for the yard unit. Having inherited the Sumerian culture that created cubits, Babylonians had a measurement system based on the sexagesimal system. The Babylonian unit of time and angles continue to be used today. On the other hand, although the ancient Greeks had the most developed scientific system at the time, they did not develop a measurement system. Then, the Roman duodecimal system became widespread in Europe, mixed with each country's traditions, and led to the development of various measurement systems. However, all of these systems remained within the framework of the Babylonian measurement system. During the reign of Queen Elizabeth, England unified the measurement system and established a new yard-pound system based on Babylonian base 60 system. France inherited the Roman law, but during the Revolution, there were growing calls to reform the measurement system. On January 1, 1840, the French Academy of Sciences created and implemented the metric system. Later, Germany followed suit and adopted the metric system, and over time most countries around the world accepted the metric system. Of course, some countries continue to use traditional systems, such as the yard-pound system. In ancient China, many countries struggled for power for over 200 years. The Jin Dynasty located in the western region grew in power, eventually becoming the most dominant country. Jin Dynasty employed various methods, ranging from invasion, looting, blackmailing, and conciliation, taking over 6 other kingdoms one by one. In 221 BCE, with the collapse of Qi in the northwest, the last of the standing countries, China was unified under one monarch for the first time in Chinese history. Hence was the making of China's first emperor, Qin Shi Huang. Qin Shi Huang employed a strict and centralized authoritarian rule. To do so, he first unified the different ways of measurement in the countryside and standardized laws in written language. He also started constructing roads and canals, as well as a wall that would connect the fortresses in the northern borders, which came to be known as the Great Wall of China. We can infer from the astronomy or currency used at the time in civil engineering, architecture, and ship and carriage building technology that the ancient Chinese culture had a sophisticated measurement system. Shang and Zhou dynasties built institutionalized systems, creating a new measurement unit Zhouqi. This later became the basis for the Chinese units of measurement. 1 Zhouqi was around 8 inches. What about the unit that was used for length in ancient China? The standard unit of measurement for length at the time was qi. The length of qi changed according to the times and the ruler being used. The average length of a qi was approximately the length of an adult foot or the span of a hand. 1/10 of a qi is kun, which means joint in Chinese character. This is approximately the width of a finger of an adult. As we can tell from qi and kun, people in the past used a hand as the standard of measurement. However, as the types of rulers and standard for determining a unit of length change for various reasons, units such as qi and kun stop being relevant to the hand or the width of a finger. In the end, kun came to be used only as a unit that is 1/10 of a qi. There were no units smaller than qi, but as the economy and science developed, it became important to measure the length more precisely. As a result, 1/10 of a kun was made into a new unit called fen. Korean ancestors called it using a Korean term, poon. When Qin Shi Huang unified China and founded the Jin Dynasty, he organized its laws and created a system of measurement. Han Dynasty inherited this system, and Tang Dynasty used the Han system as a standard to reorganize customs in local areas. As a result, 2 types of units of measurement came to be recognized. During the Qin Dynasty, the unit of measurement was reorganized under the Kangxi Emperor, which continues to be used today. Using this method, length is measured by qi, weight is measured by guan, area is measured by ping, and volume is measured by xing. Smaller and bigger units were created based on these units. In modern times, scientists found a standard of measurements in nature. One of the examples is meter, which is a 10 millionth of the distance between the Arctic and the equator. 2 French scientists left Paris and each headed north and south over 6 years to measure the Earth's meridian. A violent war was raging in Europe at the time, but risked their lives to create the prototype meter. The creation of the prototype meter was followed by the prototype kilogram. With the advent of the Industrial Revolution, the metric system that only represented length, mass, and volume was not enough. At the beginning of the 19th century, the time units were added to the basic units of measurement. Since then, ampere, Kelvin, and candelonet are respectively the units of electrical current, temperature, and luminosity were created one by one. In 1971, mole, the base unit for the amount of substance, was added, completing the 7 components of the International System of Units, SI. However, with various changes to the natural environment, such as the temperature change, problems arose in that the prototype meter became longer or shorter. As a result, the laser was used to redefine a meter as the distance that light travels in a vacuum in 299,792,458 seconds. As mentioned earlier, among the 7 units confirmed by SI, the ways of defining mass, current, temperature, and quantity of materials have changed at the General Conference on Weights and Measures in 2018. The impact of the newly defined units will be massive in the fields of science given the importance of precision in them. However, this will have little significance in our everyday lives, such as business transactions, manufacturing, and health industries. The reason why South Korea acquired international competitiveness in the realm of semiconductor or automobile manufacturing is that it achieved a high level of measurement capacities. The science of precise measurement is essential to achieve industrial advancement in nanotechnology, information technology, biotechnology, and energy technology that are the foundation of the Fourth Industrial Revolution. The history of units of measurement that allowed for the measurement of all things seems like a dramatic chronicle. The ancient Chinese came up with a unit of length from the invisible notes in a melody. Akan tribe in West Africa infused all of their knowledge and culture in weights. The measurements in medieval Europe had its root in the competitive reality of life and sacred labor. The metric system from France unified measurements all around the world in a very short period of time. Scientists had greater passions than anyone else to figure out the length of the Earth meridian and the speed of light. Measurement through standard units is a core topic that permeates human history. The standard measurement units tell a vivid story of how numerous people have lived creative lives and encountered holy deaths in the various fields of culture, politics, history, science. Humanity found the tool for measurement from places closest to themselves, their own bodies. The foot became the basic unit in most cultures, which was often divided by the thickness of a finger. In ancient Greece, the foot length was called pous and the finger thickness was called dactylus, and 1 pous was equivalent to 16 dactyloi. In China, the foot length was called chi and the thickness of the finger was called kun, 1 chi was 10 kun. Parts of the human body that was used as the units for length included fingers, fingernails, hairs, palms, forearms, breadth of a hand, steps. All of these were used as units for a while. Everything has started to change as measurement became systematized and the standardized measures came to be used. Simply put, the measurement feet replaced the actual human foot, and order began to be set in place. The standard of measurement did not just naturally appear, but it was organized and developed by individuals who were designated special roles. The resulting units were artificially created and distant from nature. Setting and owning a standard essentially became a mark of socio-political power, as well as the authority of the ruler and the dignity of a deity. Whoever has ownership of a standard becomes the one with power. In early modern Europe, there were struggles and even civil wars between the local and central governments over who would create and manage the measurement to be used for business transactions and taxations. Today, the issue of measurement is of international concern. In the past, cannons used to be fired to announce noon. Once the person in power decided on a measurement unit, there was no room for dispute. However, as we started to evaluate the value of important things, measurement, a tool for determining the amount of things, become even more sophisticated and precise. As a result, measurement became unified into a universal system within a very short period of time. Measurement has now become a common language spoken by those all around the world, thereby becoming a language of communication that connects one another. How is the ability to measure nature beneficial for humans? When we hear the word measurement, we often only think of measuring things we can see, such as length, volume, and weight. However, there are many things in this world that we cannot see, but can be measured. For example, although sound is invisible, the volume of sound can be measured. Sound is a type of wave that is generated by the vibration of objects or flow of gas. The sound generated by the vibration of an object from object's vibration is structure-borne noise, and this sound changes depending on the shape and type of the object. Sound caused by the flow of air is called airborne noise. Depending on the speed and forms of airflow, other sounds would also change. The three components of sound are intensity, pitch, and tone. The intensity of sound is determined by the amplitude of frequency. The bigger the amplitude, the louder the sound. Likewise, the smaller the amplitude, the smaller the sound. Human ears react sharply to a change in quiet sounds and react more slowly to a change in louder sounds. Tone equals sound quality. Therefore, even if the intensity of sound gets 10 times stronger, human ears do not perceive it as 10 times louder, but as about 2 times louder. Decibel is a unit used to measure the intensity of sound based on human hearing. The Bell part of the unit is in recognition of Alexander Bell, who contributed to the development of long-distance telephones, and deci is a prefix that means 1/10. Being exposed to loud noise for extended periods of time not only causes pain but may also result in a hearing loss due to ruptured eardrums. By making units that measure the intensity of sound and representing it numerically, it is possible to protect our ears. Temperature is a numerical representation of how cold or hot an object is. We constantly check the temperature, such as when we say, "It is 62 degrees Fahrenheit today," or "I have a fever because of a cold." We use a thermometer to measure the temperature. There are many different units for measuring the temperature, as well. In the Celsius scale, water freezes at 0 degrees Celsius and boils at 100 degrees Celsius. The scale divides the temperatures in between into 100 scales to show the temperature. On the other hand, in the Fahrenheit scale, the range between the freezing point of water, 32 degrees Fahrenheit, and boiling point, 212 degrees Fahrenheit, is divided into 180 to measure the temperature. The Celsius and Fahrenheit scales are commonly used in daily life, but the field of scientific theory uses absolute temperature instead. Kelvin, the unit of absolute temperature adopted by Kelvin in 1848, was named after him. Because Celsius and Fahrenheit are relative, they are difficult to apply for scientific calculation. That is, 20 degrees Celsius is not twice as hot as 10 degrees Celsius. In the case of absolute temperature, however, it would be accurate to say 20 Kelvin is twice as hot as 10 Kelvin. Absolute 0.0 Kelvin is minus 273.15 degrees Celsius or minus 459.67 degrees Fahrenheit. We often confuse heat with temperature in their daily use, but heat refers to the movement of energy caused by the temperature difference. To put it another way, heat is the total energy, encompassing both the energy exerted from the outside and the movement of energy from entry and exit of matter, while temperature is just the level of energy that an object has. The two concepts of heat and temperature began to be clearly distinguished and used separately since the time when the thermometer was invented, allowing us to represent temperature as an objective value rather than relying on human senses. Along with sound and temperature, everything we feel can be measured. It is even possible to measure the intensity of light. But are humans the only beings capable of measuring the intensity of light? Could plants also recognize the intensity of light? Sunflowers follow the direction of the sun's movement. Plants on the windowsill sometimes grow tilted towards the sun. How could plants recognize where the light is coming from and move to that direction when they do not have sensory organs like animals? Like most chrysanthemums, sunflowers bloom what looks like a single flower at the head of its stem. This flower is actually composed of many flowers gathered together. Sunflowers grow up to be around 2 meters tall. Its stems are lined with oval-shaped or heart-shaped leaves that grow in a zigzag. Also known as flowers of the sun or golden flowers, sunflowers follow the sun from the east to west before their flowers bloom. Once the flowers bloom, their heads droop toward the south. To get nutrition required for the flowers to bloom, only the green flower buds, the stems, and the tips of the leaves move along with the sun. At night, these parts reorient themselves eastward to face the rising sun. This does not mean that the sunflower is capable of measuring the intensity of light. Sunflowers only move instinctively to get the nutrition necessary to sustain their lives. Thanks to the development of scientific technology, it has become possible to observe the world that we cannot see with our bare eyes, and units for measuring minuscule sizes have been created. As a result, minations has become a rapidly developing field of study. At the same time, units of measurement that are extremely big, allowing us to measure the vast universe, have also been created. If we were to mark the distance between the Earth and Moon or the distance between stars in miles or kilometers, even trying to read the number would be a challenge. However, we can measure or study the vast universe using a new unit of light years. A light year refers to the distance that light travels in a vacuum in 1 year. In astronomy, astronomical unit and parsec are also widely used to measure a distance between celestial bodies. Astronomical unit is defined as the average distance between the Earth and Sun, and the definition of parsec is the distance corresponding to a second in the annual parallax. To elaborate it, parsec is a reciprocal number of the annual parallax measured in second. To put it another way, if annual parallax, A difference between the direction at which a celestial body is observed from the Earth and the direction at which it is observed from the Sun is 1 second, it is 1 parsec. If it is 0.1 second, it is 10 parsecs. Using annual parallax, it can measure only the celestial bodies that are as far as 300 light years. The celestial bodies located farther than that, indirect ways are adopted to measure a distance. In a parsec, light travels about 186,000 miles in a vacuum. Therefore, light moves about 6 trillion miles in 1 year. We call this a light year. Converted into other units, a light year is approximately 63,000 astronomical units or 0.307 parsecs. At the same time, a parsec is equivalent to about 3.26 light years or 206,265 astronomical units. What is visible can be touched. All such objects can be named. This is what the world of chemistry deals with. However, various things in this world do not have shapes, but they can still be named. Simply put, mathematics enables us to constantly give names to objects that do not have form. Although some things are invisible, it does not mean that it is impossible to measure them. We cannot see the movement of light, but it is very much possible to measure its speed. The speed of light is known to be the fastest among all known matter. As mentioned earlier, light can travel about 186,000 miles per second in a vacuum. Therefore, it moves 670 million miles per hour, which calculates to as far as 6 trillion miles a year. Light can travel around the Earth 7.5 times in a second, and it only takes about 8 minutes for the light from the Sun to arrive on the Earth. In the 17th century, Galilei thought the speed of light was finite and tried to prove it through experiments. Ole Romer was a Danish astronomer who was the first to measure the speed of light. He discovered that the time it took for Jupiter's satellites to appear again after being covered by the planet's shadow changed every 6 months. He hypothesized that this happened because the distance between Earth and Jupiter changed due to the Earth's revolution. After many observations and numerous trials and errors, he finally succeeded in measuring the speed of light. Although it was somewhat different from the speed of light known today, Romer's achievement was significant in that he was the first to measure the speed of light. There was one occasion where a mix-up between kilogram and pound came close to ending in a tragic accident. Commonly known as Gimli glider incident, it was an emergency landing of Air Canada Flight 143. On July 23, 1983, Air Canada Flight 143 with 61 passengers and 8 crew members on board were heading smoothly to its destination. But, all of a sudden, the engine stopped. Although there was no problem with the engine, the plane ran out of fuel. Unlike the existing planes, this new model of an airplane used the metric system, not the yard-pound system. Yet, the fuel was calculated in pound, so the plane did not have enough fuel to get to the destination. Fortunately, the pilot managed to make the most of his skills to glide the plane into a former Air Force base in Gimli without any casualty. This is a good example that shows old customs that we have gotten used to through tradition work as an obstacle to the standardization of units.